So I'm going next part of Airflow architecture. So this lecture I'm talking about architecture. So basically you are here and then we are accessing using web browser Airflow, and then this web browser is basically running on the master node. So master node basically have scheduler and executor, and then the data is stored in the metadata table which we called, it can be MySQL and Postgres or some other database, and scheduler have a queue, and queue they have access worker nodes 1 2, there may be another worker nodes. So this is high level. So basically core component is here. I'm going to talk about 4. Web server. So web server is basically like this server which I'm talking. This is a Flask-based web application used for viewing and managing workflow, right? This is, it provides user-friendly interface, monitoring workflow executor and their outcomes, editing and managing DAG, direct acyclic graph, and managing Airflow environment. So this is what we, first one is web UI, web server. Then scheduler. So scheduler is here, okay. So the heart of Airflow scheduler is workflow based on dependency schedule in defined DAG. Scheduler is trigger tasks and run their schedule time and manage their execution. So this is the execution, right? And it is continuous fall for task and to be queued and send them to be executor. So it's in continually in the queue. So when the time will come, it will run executor. So we are talking about executor, responsible for executing task and executing send to it. Airflow supports several type of executor, scaling task. One is sequentially, which is development and testing. Sequential executor. Other is a local executor with the single machine environment. Other is a Celery executor for the distributed execution Celery. So we use this one mostly. And another is Kubernetes executor for the execution of Kubernetes environment. So these are 3 things, and 4th one is metadata. So database that store metadata about all workflow and manage Airflow. It include information about structure, workflow, schedule, and execution history, and its status task, the Databricks sequential workflow. So they basically this is building blocks. So they have web server, they have scheduler, they have executor, they have metadata. Okay. So the key concept in my previous lecture, I talk about direct acyclic graph, then operator, then task and task instance, right? So scalability and extensibility. Airflow architecture support scalability throughout a pluggable executor model, which allow run task variety of background system. Okay, so we will cover it here, the big picture, scheduler, web interface, executor, database, working, Airflow, those config. So we talk about scheduler, web server, database, executor. Here are the pictorial representation already I said, and database also used for some of the use SQL, Alchemy or relational object model they are used. So we need to also learn SQL, Alchemy. So this is also used. So you're going to learn this one. Airflow parse all the DAG and background at a specific period, the default period using the process fall interval, right? Once the DAG file is a parse, a DAG run created based on the scheduling parameter, task instance is initiates, need to be executed and they're scheduled, metadatabase. The scheduler is responsible for querying database and retrieving the task scheduled state, distributed them to executes, and the state of task change to queue. The queue task is drained from the queue by worker and execute. The task status change the running. When the task finish, the worker running mark either failed or finished. The scheduler then update the final status in metadata table. The final step is airflow.cfg. Airflow comes with a lot of knobs and level can be knocked to construct desired performance from Airflow cluster. For instance, processor fall interval config value is previously discussed, can be changed frequently, which Airflow parse DAG and background. Another config value is the scheduler heartbeat second. Control how frequency Airflow schedulers should attempt to look the new task run. If set to fewer heartbeat second, then Airflow scheduler will check the more frequently to trigger new task, placing more pressure metadata table, yet another config job heart second, determine the frequency which task instance listen the external kill configuration. When using CLI or UI clear the task, you can find the detail in configuration. Yeah, so this is how in this topic we learn about this 4 component. First is web server, scheduler, executor and metadata, and then queue is Redis and RabbitMQ also can use, and there is 3 or 4 techniques which can Airflow run. Those are Celery, local mode, and which executor, the sequential mode, Celery executor, local modes. So these are things which we learn. Database also, this is very important part, so you guys can learn. Thank you for watching. Please like and subscribe my channel.